Inverse exists if and only if it is a non-singular. Non-singular means determinant of A is not equal to 0. Once if you are familiar with finding the adjoint, you can find the inverse. So inverse is nothing but 1 over determinant of A into adjoint of A. Instead of writing the elements in first row, second row and third row, if you represent the elements in first column, second column, third column, straight away you will get the adjoint. Hello dear students, welcome to this session of Mathematical Foundation class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the cofactors and the adjoint of a square matrix. Now today in this session, I am going to discuss very important concept that is called the inverse of a non-singular matrix. Inverse exists if and only if it is a non-singular matrix. You know, non-singular matrix means determinant of A is not equal to 0. So this is very important concept. Now let us discuss regarding the inverse of a non-singular matrix. Inverse exists if and only if it is a non-singular. Non-singular means determinant of A is not equal to 0. If determinant A is not equal to 0, then only the inverse exists and it is denoted as A inverse. So a square matrix A is invertible if and only if A is a non-singular matrix. If and only if A is a non-singular matrix, then only the inverse exists, and that is called an invertible matrix. A is called an invertible matrix. So the inverse of A is obtained by using the formula A inverse is equal to 1 over determinant of A into adjoint of A, or A inverse is equal to adjoint of A divided by determinant A. So therefore the inverse of a matrix A is equal to 1 over determinant of A into adjoint of A. See, since if determinant A is not equal to 0, then inverse exists. If determinant A is equal to 0, if you divide any number by 0, it is an infinite number. So therefore, the inverse does not exist for a singular matrix. Now you know the adjoint of a square matrix is given by the transpose of a cofactor matrix. The transpose of the cofactor matrix is called the adjoint. Very important concept. You may expect one question for 5 marks or 8 marks. Definite question from this concept. Inverse of a square matrix. So what is the formula for inverse? The inverse of a square matrix A inverse is equal to 1 over determinant of A into adjoint A, or adjoint of A divided by determinant A. So inverse exists if and only if determinant of A is not equal to 0. Let us take an example, simple example. Find the inverse of A is equal to 3, 2, 1, minus 1. Check whether it is a singular or non-singular matrix. Find out the determinant of this. Determinant of A is equal to determinant 3, 2, 1, minus 1. This is equal to, just you know the multiplication. 3 into minus 1 is minus 3, minus 1 into 2 is minus 2, this is equal to minus 5. So not equal to 0. Determinant of A is equal to minus 5, not equal to 0. Therefore, A inverse exists. A inverse exists. Therefore, A inverse exists. A inverse exists. What is the formula for A inverse? The inverse of A is equal to 1 over determinant of A into adjoint of A. Now this is equal to 1 over, what is determinant of A? Minus 5 into, you know how to find the adjoint of 2 rows 2 column matrix. In the previous class I explained to find the adjoint for this matrix. Adjoint of A is equal to, just interchange the principal diagonal elements. 3 minus 1 can be written as minus 1 and 3, and changing the signs for the secondary diagonal elements. Minus 2 and minus 1, plus 2 becomes minus 2 and plus 1 becomes minus 1. So this is an adjoint. Therefore, A inverse is equal to 1 over determinant 1 over minus 5 into adjoint of A is equal to minus 1, minus 2, minus 1, minus 3. That's it. This is the inverse of a given square matrix of order 2 rows 2 column. Right. So this is how we are going to find the inverse. Let me take one more example. Find the inverse of matrix B is equal to minus 1, 5, 0 and minus 2. Now check whether it is a singular or non-singular matrix, whether the inverse exists for this or not. Now determinant of B is equal to minus 1 into 2 is plus 2, minus 0 into 5 is 0, this is equal to 0. 2 minus 0 is equal to 2, not equal to 0. So determinant of B is not equal to 0. Therefore, B inverse exists. Inverse of B is exists. And what is the formula for B inverse? Inverse of B is equal to 1 over determinant of B into adjoint of B. Adjoint of B. Now find out the adjoint of B. Adjoint of B is equal to, straight away you can write, interchanging the diagonals, -1 and -2 can be written as -2 -1, and changing the signs for this -5 and -0 is nothing but +0. So therefore B inverse is equal to 1 over 2. What is determinant of B? 1 over 2 into -2 -5 0 and -1. This is how we are going to find the inverse for a 2 rows 2 columns. So in this concept, see here, once if you are familiar with finding the adjoint, you can find the inverse. So inverse is nothing but 1 over determinant of A into adjoint of A. Hope you got an idea, right? Very simple concept. Just find out the adjoint and divide it by the determinant value. Now let us take this type of problem. So you may expect this type of questions for 7 or 8 marks. This is 7 or 8 mark question, very important concept. If A is equal to 2, 3, 1, -4, another matrix B, consider this as B is equal to 1, -2, -1, 3, then verify that AB whole inverse is equal to B inverse A inverse. Now let us consider this as A. Let given A is equal to 2, 3, 1, -4. Find out the determinant of this. Determinant of A is equal to determinant 2, 3, 1, -4. So this is equal to -2 4s are 8, -1 3s are 3. This is equal to -11. So determinant of A is equal to -11. Now find out the adjoint of this. So adjoint of A is equal to, interchanging the diagonals. Interchange the diagonals for this. 2 and -4 can be as -4 and +2, and the signs for this is, so therefore the adjoint of A is equal to, interchanging the diagonals. So 2 and -4 can be as -4 and 2, and changing the signs for the secondary diagonals, -3 and -1. So therefore the inverse of A inverse is equal to 1 over determinant of A into adjoint of A. That is A inverse is equal to 1 over determinant is -11 into adjoint of A. Adjoint of A is -4, -3, -1 and -2. This is the inverse of A. Similarly, now let us find out the inverse of B. What is matrix B? B is equal to 1, -2, then -1 and 3. Find out the determinant of B. Determinant of B is 1, -2, -1 and 3. So this is equal to 3 ones are 3, minus into minus plus, 1 into 2 is 2, that's equal to 1, not equal to 0. Now therefore B inverse is equal to 1 over determinant of B into adjoint of B. 1 over determinant of B is 1 into adjoint of B. Just interchange the diagonal elements. +1 and +3 can be as 3 and 1. 1 and 3 becomes 3 and 1. And changing the sign, -2 becomes +2 and -1 becomes +1. So therefore B inverse is equal to 1 by 1 is 1 into any matrix is equal to the same matrix 3, 2, 1, 1. This is inverse of B. Now what is to prove? To prove that AB whole inverse. Now just find out AB now. Multiply these two matrices A and B. Now what is A? 2, 3, 2, 3, 1 minus 4, 1 minus 4, and the matrix B. B is equal to 1, -2, -1 and 3. Multiply this. First row, first column, second column. This is equal to 1 2s are 2, -3 1s are 3. Again same row, second column, 2 2s are 4, plus 3 3s are 9. Again 1 into 1 is 1, minus into minus plus, 1 4s are 4. Again 1 into 2 is -2, minus 3 4s are 12. This is equal to 2 minus 3 is -1, 9 minus 4 is +5, 4 plus 1 is also 5, and -2 minus 12 is -14. Now just find out determinant of AB. Determinant of AB is -1, 5, 5 and -14. Multiplied, minus into minus plus 14, minus 2, 5 5s are 25. This is equal to -11. So determinant of AB is -11. Now therefore AB whole inverse is equal to 1 over determinant of AB into adjoint of AB. Now this can be written as -1 over 11 into adjoint of AB. Determinant of AB is -1 over 11. Adjoint of AB, just interchange the diagonal. -1 and -14 can be as minus 14 and minus 1. Then this becomes minus 5 and minus 5. Let us represent this as equation number 1. This is how we are going to find AB inverse. Listen to me. So after finding A inverse and B inverse, find out AB first. AB multiply as usual matrix multiplication. AB inverse is equal to 1 over determinant of AB into adjoint of AB. Now let us represent this as equation number 1. Now on the other hand, what is to find B inverse A inverse? Let us write down the RHS. This is LHS. This is LHS. Write down RHS. RHS is nothing but B inverse into A inverse. What is B inverse? B inverse is 3, 2, 1, 1 into what is A inverse? A inverse is equal to minus 1 over 11 into minus 1 over 11 times minus 4, minus 3, minus 4, minus 3, minus 1 and 2. So this is minus 1 over 11 into multiply. So 4 3s are 12. Again, minus 2 1s are 2. 3 3s are 9, minus 9, plus 2 2s are 4. Again, 1 4s are 4, minus 4, minus 1 1s are 1. Again, 1 3s are 3, plus 1 2s are 2. This is equal to minus 1 over 11 times. What is this equal to? Minus 12 minus 2 is minus 14. Again, minus 9 plus 4 is minus 5. Minus 4 minus 1 is minus 5. Again, minus 3 plus 2 is minus 1. This is equation number 2. See equation 1 and 2. 1 contains minus 1 by 11 into minus 14, minus 5, minus 5, minus 1, minus 5, 1. So from 1 and 2, LHS and RHS are same. So therefore, we can write, therefore, from 1 and 2, LHS is equal to RHS. What we say? AB whole inverse is equal to B inverse into A inverse. This is called the reversal of inverses. AB whole inverse is equal to AB whole inverse is equal to B inverse A inverse. This is called a reversal of inverses. Very important problem for 7 or 8 marks. Hope you followed. Okay. Now let us take it, how to find the inverse of a third order matrix, third order determinant. Right. Now let us take an example of 3 rows, 3 column. Find the inverse of A is equal to, let us write down the determinant of A. Determinant of this is 1, 3, minus 1, 1, minus 1, 1, 2, 2 and 3. Check whether it is a singular or a non-singular, whether the inverse exists or not. So expansion with respect to first row plus, minus and plus. This is 1 into 1 3s are 3, minus 2, minus 1 into, this is gone, 3 3s are 9, minus into minus plus. This row and column is deleted, plus 2 into 1 3s are 3, minus into plus it is minus. So 1 into minus 5, minus 1 into 11, plus 2 into 2, minus 5, minus 11, plus 4. So this is minus 4, minus 5 plus 4 is minus 1, minus 11. This is equal to minus 12, not equal to 0. The inverse exists. It's minus 12. Determinant of A is minus 12. Therefore, A inverse exists. So determinant of A is equal to minus 12, not equal to 0. Therefore, A inverse exists. A inverse exists. And A inverse is given by, what is the formula? 1 over determinant of A into adjoint of A. This is the formula. Now just go on finding the cofactors matrix. So write down the cofactor matrix. Just the signs for this is plus, minus and plus, plus, minus, plus, minus, plus, minus, plus, minus and plus. Diagonals are positive, both positive, that is principal diagonal and secondary diagonals are positive, remaining are negative. Now let us find out the cofactors for all the 9 elements. Cofactor of the first element 1. You can also represent this as A11. Capital A11 is a cofactor of small a11. So this is equal to, just let me explain in detail one step. I will explain for first row. This row column is gone, minus 1, 2, 1, 3, minus 1, 2, 1, 3. This is equal to 1 3 is a 3, minus 2. This is equal to minus 5. Similarly, cofactor for second element, cofactor of 1, again 1 is equal to, so this is negative. This row and column is deleted, 3, 2, minus 1, 3, 2, minus 1 and 3. Simplify this. This is minus out, 3 3s are 9, minus into minus, plus 1 2s are 2, 9 plus 2 is 11, along with negative side, minus 11. And the last element, cofactor of 2. that is last element, that is third element of first row. So this is again a sign, the sign is positive, this row and column is deleted, 3 minus 1 minus 1 1, 3 minus 1 minus 1 1. So this is equal to 1 3 is a 3, minus into minus plus, plus into minus minus, 3 minus 1 is equal to 2. So these are the cofactors for first row, minus 5, minus 11 and 2. Now let us come to the second row. Find out the cofactors for second row. I'll write the matrix here. Determinant of this 1 1 2 1 1 2, then 3 minus 1 2, again minus 1 1 3. The signs are plus minus plus minus plus minus plus minus and plus. Okay. Now let us expand the cofactors for the second one. So cofactor of 3, it is minus. I can explain, I can solve directly, or let me explain in step by step. So cofactor of 3 is equal to, this row and column is gone, 1 2 1 3, this is equal to 1 3 is a 3 minus 2, this is equal to minus 1. Similarly cofactor of minus 1, the sign is positive, this row and column is deleted, 1 2 1 3, 1 2 minus 1 and 3, this is equal to 3 1s are 3, minus into minus plus, that's equal to plus 5. And the cofactor of this 2, what is the sign for this? It is minus, negative sign, minus, this row column is gone, 1 1 1 1 minus 1 1, minus 1 1s are 1, minus into minus plus, that's equal to minus 2. So the cofactor for second row is minus 1 5 and minus 2. Now similarly find out the cofactors for a third row, that is cofactor of minus 1. Cofactor of minus 1 is equal to, this row column is gone, so this row column gone, 1 2 1 1 2 minus 1 and 2. So 2 minus into minus plus, that's equal to 4. Similarly the cofactor of 1 is equal to, the sign for this is minus, negative sign, this row and column is deleted, 1 2 3 2, 1 2 3 2, this is equal to 2 1s are 2 minus 6, minus of minus 4, this is equal to plus 5. And the cofactor of last element plus 3 is equal to, the sign is positive, this row and column is deleted, what is left over is only this much, 1 1 1 1 3 minus 1. Simplify this. So that is 1 1s are 1 minus 3, that's equal to minus 4. So the cofactor for the last row is 4 4 and minus 4. Now write down the cofactor matrix. If you want, you can write the cofactor matrix, or straight away you can write the adjoint of this matrix. So the cofactor matrix C is equal to, write down the cofactors. What are the cofactors in the first row? First row we got minus 5, minus 11 and plus 2. Minus 5, minus 11 and plus 2. For the second row, what are the cofactors? Minus 1, plus 5 and minus 2. Minus 1, plus 5 and minus 2. Minus 1, plus 5 and minus 2. And in the third row, what are the cofactors? Plus 4 and minus 4. 4, 4 and minus 4. Now, therefore, the adjoint of this is C dash. The transpose of this C dash is equal to adjoint of this. Transpose this. Minus 5, minus 11, plus 2, minus 1, 5, minus 2, 4, 4 and minus. So, if you want, you can write out the cofactor and transpose, or straight away you can write the adjoint. Just represent the elements. Instead of writing the elements in first row, second row and third row, if you represent the elements in first column, second column, third column, straight away you will get the adjoint. If you put the elements in row, that is cofactor. If you put those elements in the column wise, then it is called the adjoint. Therefore, the final A inverse is equal to 1 over determinant of A into adjoint of A. 1 over determinant of A. What is the determinant of A? Minus 12. 1 over minus 12 into these elements. Minus 5, minus 11, 2, minus 1, 5, minus 2, 4, 4, minus 1. This is called the inverse. That's it. Now, let us come to the next problem. Let us take one more problem to find the inverse. Find the inverse of A is equal to, what is A? 1, 3, 1, 1 minus 2, 2, minus 1, 0 and 3. Now, let us find out the determinant of this. So, check whether inverse exists or not. 1, 3, 1, 1 minus 2, 2, minus 1, 0 and 3. So, expand with respect to first row. So, 1 into minus 2 into 3 is 6, minus 6, minus 0 into 2 is 0, minus 3 into this row and column is deleted, 1 into 3 is 3, minus into minus plus, 1 2s are 2, plus 1 into this row column is gone, 1 into 0 is 0, minus into minus, plus into minus, minus 2. So this is 1 into minus 6, minus 3 into 5, plus 1 into minus 2, minus 6, minus 15 and minus 2. So this can be written as minus 6, minus 15, minus 2, that is minus 6, minus 17, that's equal to minus 23. So determinant of A is equal to minus 23, not equal to 0. Therefore, A inverse exists. So A inverse exists and A inverse is equal to 1 over determinant of A into adjoint of A. Now, just find determinant of A is minus 23. Now, find out the adjoint by finding the cofactor. That's it. Okay. Now, let us find the cofactors for this. I will write the matrix here. A is equal to det 1 3 1. Then second row 1 minus 2 2 and minus 1 0 3. So the signs, as you know, plus minus plus minus plus minus plus minus and plus. Now just find out the cofactors. Cofactor of 1 is equal to this row column is deleted. I will write in detail 0 3. This is 2 into 3 is 6, minus 6 minus 0. This is equal to minus 6. Similarly, the cofactor of 3 is equal to, the sign is negative. This row column is gone. 1 2 1 2 minus 1 and 3. So this is equal to minus of 3, minus into minus plus, that's equal to minus 5. Similarly, cofactor of 1 is equal to, this row column is gone, 1 minus 2 1 minus 2 minus 1 and 0. This is 0 minus into minus plus into minus minus, that's equal to minus 2. So for the first row, the cofactors are minus 6, minus 5, minus 2, right? So let us similarly find out the cofactors for second row. Cofactor of second row, first element, that is 1 is equal to, what is the sign? It is minus. Right away I'll do, instead of doing this step, I'll reduce one step and I'll straight away do like this. So this is gone. 3 3s are 9 minus 0. 9 minus 0 is equal to 9. Minus into plus, it is minus 9. Similarly, cofactor of minus 2. It is positive. This row and column is gone. 1 3s are 3 is gone. This row and column is gone. 1 3s are 3. Minus into minus, it is plus. 3 plus 1, this is equal to plus 4. Again, cofactor of 2 is equal to minus. This row and column is gone. What is left is 1 into 0 is 0. Minus into minus plus 3, that is equal to minus 3. Minus 9, 4 and minus 3. Now, similarly, find out the cofactors for the third row. Cofactor of minus 1. So, this row and column is gone. 3 2s are 6. Minus into minus plus, 1 2s are 2, that's equal to 8. Cofactor of that is 8. Cofactor of 0 is equal to minus, negative sign. This row column is gone. 1 2s are 2 minus 1. 2 minus 1 is equal to minus 1. And cofactor of last element 3. 3 is equal to, see, this row and column is deleted, only this much. 1 into minus 2 is minus 2 minus 3. Minus 2 minus 3 is equal to minus 5. Okay. Now, therefore, straight away we can write the adjoint. Adjoint of A is equal to, instead of writing the cofactor matrix, instead of writing first row, second row, third row, if you represent in first, second and third column, you will get the adjoint. So, therefore, adjoint of A is equal to, what is this first column contains? Minus 6, minus 5 and minus 2. The second row is 9, 4. This can be as second column, 9, minus 9, 4 and minus 3. And the third row can be written as third column, 8, minus 1 and minus 5. So, this is the adjoint. So, therefore, A inverse is given by A inverse is equal to 1 over determinant of A into adjoint of A. 1 over, what is determinant of A? Determinant of A is equal to minus 23 into adjoint. This is the adjoint. Minus 6, minus 5, minus 2, minus 9, 4, minus 3, 8, minus 1 and minus 5. This is the inverse. Minus 1 over 23 times the matrix is the inverse of the given matrix. That's it. So, if you do this much, definitely you will get 8 marks for this. This is a 8 marker question. Very important, a sure question. Definitely will expect this type of questions. That's it. Hope you followed. You got an idea how to find the adjoint and the inverse of a square matrix of order 2 rows 2 column and 3 rows 3 column. That's all regarding today's session. Let us meet with the different concept in the next session. Thank you. Thank you very much.